Hello, AP Psychology students. This is part 2 of conducting research in psychology. In part 1, we looked at descriptive research methods. In part 2 here, we're going to look at correlational research. And in part 3, we'll be looking at the details of experimental research. Correlational research is a really important research tool, especially when it would be somewhat unethical to study something with an experiment. For example, we know that drinking alcohol during pregnancy is correlated or related to low birth weight. But it would be pretty unethical to do an experiment where you give pregnant women, tell them to drink 4 shots of whiskey per day and let's see what happens to the baby. Probably not a good idea. They might end up with fetal alcohol syndrome. They might end up with a premature birth or whatever. But we can look at the relationship between two variables, such as drinking or using cigarettes during pregnancy. So we can predict a behavior or an outcome based on this relationship that we see. And we can also, so what we use is 2 behaviors, events, or other characteristics that can change or vary in some way. And that's kind of important to think about because what we're going to be using, and I'll show you in a minute, is a scatter plot to take a look at the amount of a relationship that we might see. So when we're collecting data, we can use other methods of research such as surveys, archival research, and observation to collect the data. So if we wanted to say, for example, see if there was a relationship between and I'll talk about this later, but like the hours of social media use and self-esteem, we might be able to actually look on a computer or a iPhone or something and figure out exactly how much social media someone is using per week, and then we can give them a survey of some kind to look at their self-esteem. So that's how we would have the 2 variables, and then that is how we would use different methods to obtain our data. So when we talk about correlational studies, what we use to describe the strength of the relationship is a correlation coefficient. This is a number we call R for relationship equals, and then this is a number between +1 and -1. So on a chart, we would have -1 on one side and +1 on the other, and we would take that R value, and the closer that R value is either to the +1 or to the -1, the stronger the relationship that we see between the 2 variables. And so that we can say we can predict that one variable might result in the other variable, but again, we cannot prove cause and effect. So a positive correlation is a direct relationship. So I know that part of the grid is obscured by my picture here. I'll try to fix that for future presentations, but we're looking here at a grade point average on the y-axis and hours of studying per week on the x-axis. So you think about that. Would one predict that the GPA will go up as the hour studying goes up? And so in this graph here called a scatter plot, we see that there is a fairly direct correlation, in fact, a pretty strong one, because those points are clustered closely together. So we see, let's say if this is a 4.0, we see the hours studying here, maybe it's 12 hours per week, and we see that the general direction of the line is up and to the right. That's going to indicate a positive correlation. Now, a negative correlation is going to have an inverse relationship. So here we'll take something like hours of TV watched per week and grade point average. And you see here that as the number of hours goes up, that the grade point average goes down. So we have quite a low grade point average here. So we can predict that if someone has either a low GPA, that perhaps they're watching a lot of TV, or we maybe can predict that if someone's watching a lot of TV, really into Netflix, that they will have a low GPA. Now that may not always be true, but again, the scatter plot here reflects a fairly close relationship, a number close to -1. A zero correlation here so grade point average and number of apples per week. When you see a scatter plot that looks something like this, you're going to see that there is really no general pattern that we can assess from this scatter plot, and therefore we can conclude that there's no relationship between apples and grade point average. I want you to remember one lesson in my stats class in college at university. I just remember my professor saying, if you remember one thing from this class, remember, correlation is not equal to causation. Now, in election seasons, people will all the time, like politicians, ads, whatever, they'll be taking correlational statements or studies and claiming them to be causal, but that is simply not the case. They only allow us to look at a relationship or a prediction. The thing is, there might be an unmeasured third factor that we cannot identify. So, for example, let's say that a child watches PBS shows like Sesame Street, like, an hour a day, and their reading level seems, the amount of Sesame Street that a kid watches might be positively correlated with their reading level, because that show looks at, reading and letters and things like that. But that third factor might be that perhaps that family values reading and they read to their kids, and that's why, and then they also value Sesame Street, and that's why the kid is actually reading better, is because the parents are reading to the kids. The other thing that we need to watch out for is something called an illusory correlation. So I have kind of a funny video to show to illustrate an illusory correlation. And here we go. I have to recenter it somehow, but I'll get it started.
Age films are released the same year? Turns out there is a 66.6% correlation between the two. Or how about the fact that there's a 99.26% correlation between the divorce rate in Maine and the per capita consumption of margarine, or a 99.79% correlation between spending on science, space, and technology, and the number of suicides by hanging, strangulation, and suffocation. Just because there is a correlation between two variables doesn't mean that one causes the other. This assumption is a logical fallacy, and yet we're drawn to headlines like, "People who have more sex make the most money." Unfortunately, this does not always equal that. Even though it may look like it, cheese consumption probably isn't related to how many people die tangled in their bedsheets. But sometimes it isn't so obvious. Numerous studies found that menopausal women taking hormone replacement therapy had a lower than average incidence of heart disease, leading doctors to believe that hormone replacement could protect against heart disease. However, when women underwent randomized control trials, they found that hormone replacement therapy actually increased the risk of heart disease. When the original data was finally reanalyzed, it was found that women who took the therapy were of a higher socioeconomic group with a better diet and exercise regime. This was the real cause behind decreased risk of heart disease. Another case found that those who used nightlights as a kid were more likely to develop myopia, but there's actually a strong link between parental myopia and the development of child myopia, so in reality, myopic parents were simply more likely to leave a light on in their child's bedroom. These are examples of a lurking variable, where A does not cause B, but rather C causes them both.
Okay, so I think you get the idea, and I'll try to fix the videos in the future as well. So I know that was a little bit off, but the important point to remember here is, and I think they made this pretty clear, is that sometimes there is an illusory correlation. This is when when someone perceives a non-existent correlation. It's actually a random coincidence. So a lot of baseball players, for example, they have these routines, like maybe they tap their shoe with their bat 3 times, and then they get a home run. And so in their mind, they're like, oh my gosh, I got a home run because I tapped my shoe 3 times. So they see a correlation and maybe a causation where none actually exists. But what do instead? They go ahead and they tap their shoe every time. There's kind of this thing that I remember back when I was younger, is that people would say, well, if you are having trouble conceiving and you adopt, you're going to get pregnant. Well, that does happen for some people, and I know some people that happened for. But other people that I know adopted, and they didn't get pregnant. And so what we're more likely to look for is confirming evidence, and we're more likely to believe that. But just be careful of that concept of an illusory correlation. And finally, the video mentioned the idea of a third variable. So let's take a look at an example of this. Now, I've been talking about depression in this class, and one of the reasons is because it is something that most people know or can relate to in some way. So we might say that low self-esteem could cause depression, and there's certainly some people believe that. But depression, because it is really a complex disorder, and it might have biochemical roots as well, or other health reasons like problems with your thyroid, when you're depressed, that could cause you to have low self-esteem. So you might have, and this is where the third variable comes in, distressing events or biological predisposition. Both of those could cause either low self-esteem or depression. So again, we cannot say in a correlational research study that one variable causes the other. But what we can say is that they are related. So we know that low self-esteem and depression are related, but we don't know exactly why or in which direction they are related. So I have put an assignment on Schoology, and your ABA today is very simple. It is just to answer a couple of questions about our new hybrid learning situation. But your assignment actually due at 11:59 p.m. is to go to Schoology and find the research assignment and to think about each of these questions of interest. One of the things that I like to talk about in class is propranolol. This is a study that was done to see if getting propranolol after a traumatic event occurs will potentially prevent post-traumatic stress disorder from occurring. So what I would like you to do for each of these scenarios, there are 8, is to think about why is this an important topic to study? Who cares and why? So just an example of who might care about a propranolol study, it's pharmaceutical companies. See if you can come up with a couple of instances of who cares. I want you to be starting to think about something called the subject population. So who are we studying here? Who are the people that we are interested in studying? In this case, for number 1, we are interested in studying only people with PTSD or with a trauma. So if they've had a trauma, they could be in this study, or if they have the potential to develop PTSD, or we might even look at people with PTSD to see if it could be a treatment. The key variables we're looking at, so identify that for each of these. There might be 1 or 2 variables, depending on the research. And then finally, what is a possible method you could use? I want you to be specific here. So if you think it's a descriptive research method, say which one. Is it a survey? Is it a case study? Is it a naturalistic observation, archival research? If it's correlation, if you're trying to find the prediction or a relationship between the 2 variables, then state that it's correlational. And remember, it's only that the experiment that can prove cause and effect. So think about which of these could be an experiment and ethically be done. So, okay, so that's it for today. Thank you for your attention. Have a great day.